Hi and welcome to section 0.8, the Pythagorean Theorem. And before we actually get to the Pythagorean Theorem, we first have to cover the parts of the triangle. The first one is the hypotenuse. And so now in a right triangle, these are right triangles, and the Pythagorean Theorem, please note that the Pythagorean Theorem only works in right triangles. Again, one more time, the Pythagorean Theorem only works in right triangles. So hypotenuse is in a right triangle, is the side opposite of the right angle. So here is the right angle, donated by the square in the corner. The hypotenuse is always across from the right angle, so this red line, that red line would be the hypotenuse. The legs are what make up, what form that right angle. So this and this would be the legs. Let's get to the Pythagorean theorem. Pythagorean theorem is known as a squared plus b squared equals c squared. Again, a squared plus b squared equals c squared. And how it reads, if the triangle is a right triangle, again it only works for right triangles, then the sum of the squares of the lengths of the legs, AB, equals the square of the length of the hypotenuse. And so C being the hypotenuse, that's a very important key, C being the hypotenuse. So let's get into a couple examples, starting with number 1. First, we are given the lengths of the triangle, so we are going to use this formula, the Pythagorean theorem, a squared plus b squared equals c squared. We have to find a, so what I'm going to do, I'm going to plug in all my measures that I know. So I do not know a squared plus, I'm going to plug this 6 in for b, so it's 6 squared equals, plugging the 7 in for c, 7 squared, so we have a squared plus 36 equals 49. Now we have to solve for a squared. How do we do that? We have to subtract 36 from both sides, leaving us with a squared equals 13. Now we have a square attached to the a. How do we undo the square? We have to square root both sides, and now you just type it into your calculator. So a equals 3.61. Next, number 2. Now if it gives you just letters and numbers, a equals 4, c equals 9, you can go ahead and plug them right in, or if you want to, you can put them on your triangle. So I'm making this side a, and this has to be the hypotenuse, right? Because it is across from the 90-degree angle. So just remember, it does not matter what the a and the b is, but it does matter that the c is a hypotenuse. So again, I'm going to use our awesome formula, the Pythagorean theorem, plug things in. So a was 4 plus b squared equals 9 squared. Multiply out your squares, so we have 16 plus b squared equals 81. Subtract 16 from both sides, so we get b squared equals 65. Again, how do you undo a square? You have to square root both sides, so b equals 8.1. Now I rounded up there, it really equaled 8.06, so I rounded up just to the tenths place, which is fine for right now. Next, one more. Here we have a and b. If you want to, you can draw a triangle. Put it down. Where are your a and b? It's 6 and 7. Go ahead and plug that right into your formula. So we have 6 squared plus 7 squared equals c squared, because we do not know what c is. So now we multiply everything out. 36 plus 49 equals c squared. 85 equals c squared. How do you undo a square? You have to square root it. So we square root both sides to get c all by itself equals 9.2. Last example, the converse of the Pythagorean theorem. Now it states if the sides are a triangle that have the lengths ABC, just like what the Pythagorean theorem did, and this is true, so the hypotenuse squared equals the sides squared and added up, then it is a right triangle. Right? So let's see what we can do with this. So when they give you we're asked to tell whether the triangle with the given side's length is a right triangle. When they give you just three lengths, the longest side is your hypotenuse. We have to make sure that the longest side is your hypotenuse. That goes in for C. The other two smaller numbers, it doesn't matter. They can go in for A or B, but we have to know what our hypotenuse is, and it has to go in for C. So I circled the hypotenuse on the screen, so we have 17 squared, and now it equals, we're just plugging 8 in for A, 15 in for B. You could also plug 8 in for B, 15 in for A, but I chose to do it like this. So we have 8 squared plus 15 squared. Moving right down the line, we have 64 plus 225 equals 17 squared is 289. So far this doesn't tell us too much, but what if we add those black numbers together? We come up with 289. Uh-oh. So 289, does 289 equal 289? You betcha it does. So since this is equal to each other, this is a right triangle. Right? You don't have to spell triangle, you can just make a triangle, it represents triangle. Because our numbers that we came up with, 289 equals 289, it is a right triangle. If this was 280 and this was 289, it would not be a right triangle because they did not equal each other. So again, if they equal each other, it's a right triangle. If they don't equal each other, it's not a right triangle. Thanks for tuning in to 0.8, the Pythagorean Theorem.